boys and girls. So today we're going to be doing a review of some of the parts of Chapter 1. Even though we're not done with Chapter 1, I want to give you guys a review of what's going on and what you should be getting from this material so far. We've been introduced to 3 different claims that answer the question of what caused the severe storms in Galetown. Claim 1 is that the lake caused the storms. Claim 2 is that the warmer weather. And claim 3 is the more violent wind and other things outside of the rain. So we've kind of dabbled into all 3 claims as we introduce the unit, but as we're ending Chapter 1, we kind of want to focus only on claim 1. And claim 1 is that there is there's more rain because there's more water. So when you guys were introduced, we had this idea of a water cycle, and I'm going to draw just the basic parts of what you guys were given in the beginning, right? So we have some land here, the mountain, and the water. In this claim, the large body of water would be the lake. So I'm going to color it in some water. Okay, so to get started, we have 3 major terms that we need to introduce. So I have the sun here, which is our source of energy. And our source of energy, remembering that energy means has the ability to make things change or move. And the thing that the energy is changing is the water phase. So as you watch me struggle with tape, there we go. So the evaporation. We know that the sun beams down onto the large bodies of water or any surface water. In the last couple lessons, you would have learned that surface water is water that's available and exposed to sunlight. Now, large bodies of water have more surface water, whereas you might find some surface water on the tops of mountains when there's snow, or even puddles that are on the ground. They all evaporate. It has to be exposed for it to evaporate. Then, as it moves through the troposphere, the water goes back to liquid form in the condensation. This is what we have as clouds. So in the cloud, right, the water goes liquid to gas, gas back to liquid. Once it gets too heavy, once gravity can have a strong enough hold onto this water, we have precipitation, which is when it comes back down as either rain, snow, hail, right? So this is a basic model of our water system. There are a lot more words we're going to learn about, and when we get back, I have some maps of watershed, which we're going to also discuss in this video. So the surface water. In the simulations, which I'm going to go over the simulations again later in this video, the water goes up, evaporates back into gas, into gas, then condensates back into a liquid, and once it gets heavy enough, gravity will pull the water back down, and that's precipitation. So claim 1 says that the lake caused there to be more severe storms. And to look at that claim, we have to look at how much surface water is being evaporated. In the simulations, as you increase the amount of surface water, the storms get more severe. Now, it may not be as severe as what they're describing as flooding and all this other things that are going on in Galetown, but the idea that the amount of surface water is increasing the severity of the storm should be paid close attention to. You're going to need this evidence later on in the unit and later on in this chapter. So, evaporation, condensation, precipitation. The larger amount of groundwater, surface water. The larger amount of water exposed to direct sunlight would increase the amount of water vapor. More water vapor, bigger clouds. Bigger clouds or more clouds, the mass of clouds is increased. That means that there's going to be more rain. So more surface water, more cloud, more rain. So this is the evidence that supports claim 1. Okay, so I'm back onto the simulator again in the lab portion of the simulator. You should have done this experiment earlier with me or for one of your assignments that you did on your own, but I want to talk about just claim 1. And so I'm going to leave the temperature for the outside air and the temperature for the ground and the air that's being evaporated the same. And I'm not going to move those. I want to focus simply on the amount of water. So I'm going to go to a low amount of water vapor. Again, there's a low amount of water vapor because there's a low amount of surface water, meaning available for the sun to evaporate. And I'm going to see how the rainfall is reacting to this lower amount of surface area. And when I analyze it, it's almost no rainfall. So even though there is water vapor, the clouds are not forming and the rain is not happening. There is still amount of energy transfer, but if we look at here down on the bottom, rainfall is at a 0, meaning that there isn't any. So then I'm going to go back to the build and I'm going to actually go towards right around the medium. And I'm going to run this portion. So this is increasing the surface water, making more water available to evaporate and turn into water vapor. And we do see rain. As we go here, it goes to a rain level of 1. So, and it's indicated here that this rain level is mild. So as we've increased the amount of water vapor, the amount of water, there is more rainfall. Not much, but still more. I'm going to then increase it to a high. Now this would be similar to adding the lake, because as we added the lake, there's more surface water, more available directly under the sun, meaning more water to evaporate. And if we run this, almost immediately we see that it's a much quicker and more dynamic cloud, and there's definitely more rain coming down in this image. But as we analyze, we see that it goes to a moderate. As we increased water, the level of rainfall went from none to moderate. Now, the storms in Galetown were severe. So this is not necessarily enough to explain the severity of storms, but adding more surface water does show that there's more water vapor, thus more rain. I'm going to go into the regional weather one, and this was the one we used on the first day of this chapter, and I'm going to go down to a surface level of 0. No lake. I'm not changing the sun at all. I am keeping the sun at a moderate amount. And again, you can see that there's still water coming up, and it's moving up towards the troposphere, and there isn't much rain. So again, rain levels are at none. I'm going to go back to build and increase the surface water, meaning more water available for the direct sunlight. As we run, on the bottom you see that this is indicated over there being a lake. So we went from 0 to a full lake. As we increased the amount of water, we see that the clouds are definitely larger and becoming more severe. In the analyze section, we see that again, same result as the other lab. It goes from 0 to 2, a moderate. So we see that for claim 1, as we increase the amount of surface water, the severity of the storm also increases. But I do have one concern, is that it's not at a severe level. So we're going to look more closely at other claims later on in this unit to see if they can go along with this claim or if they refute this claim and cause a different scenario. But for right now, claim 1 is still true because as we see, as the increase in water, we have an increase in storm level. All right, this week you're going to be writing a CER, which is a claim evidence reasoning. I want to bring up this reasoning tool again just to help you guys understand how I expect this to be written. We've been doing a few of these already, but I want to be clear about the expectation as we move forward in the year. The question that we're asking you is claim 1 the option for why Galetown is having more severe storms? So as you go through this, you have to have evidence. And the evidence can come from the simulator or any other readings that you have or any information you have about storms. So the evidence, and then comes the reasoning. This is the most important. This is the part that where you explain why the evidence matters. This is your thoughts. This is your processing of the information. And at the end, therefore, your claim. This evidence reasoning tool comes from when we did the Coca-Cola CER in the beginning of the year. So don't worry necessarily about this information here. Just really worry about this up here. You need to answer the question. Is more surface water and the adding of the lake causing more severe storms? You can write your evidence, explain why it matters, and then give an answer. Your answer can be, yes, it's causing more severe storms. No, it doesn't cause a change in storms at all, or it causes a change, but not significant enough. So you have to give a clear piece of evidence, a clear explanation of why your evidence matters, and then state your claim in a full, complete sentence.